Okay, so here is the other sample problem I think I would wanted to discuss that I had prepared for class is class 13, and we have this like pipe thing and a little cap, and it's got this cable. For some reason it's holding up, and this cap seems to be a pretty large little plate, um, and is suspended by these two bearings right here. And one of the bearings, a B, does not support axial, and you kind of need to know that in order to, so it's not over constrained. Determine the tension in the cable and the reactions at A and B. Now, to make this a little bit more efficient, I'm feeling a little lazy. I'm going to go ahead and just walk through what my solution was. So that seems fair enough, right? It's in the book as well, but let's just walk through it and see what that looks like. So I solved it, and one of the first things I did was to define what the weight is, right? So the weight is 30 kilograms, and it's times the gravity. So I got what the newtons were, and it's in the J direction. Then I want to get some position vectors. I want to get the position vector for the cable, and I need C with respect to D. So it went 480 negative X direction, 240 upwards, and then it's going in the negative Z direction, 160, and then we get the length. So we're able to get what the force in the cable, FCD. We're able to get that as a vector, right, with the unknown magnitudes within it. Over here, I probably did this first, but I drew it right underneath there is my FBD of the thing, and you can see I represent the reactions, and I chose them all as positive, so RAX, RAZ, RAY. And none of these support a moment. This is the kind of bearing that allows some flexure, and it doesn't restrain the moment on the thing. So now I need to get that was the force of the cable. Now I want to get the position vector with respect to A, because I'm going to take A. I think the book decided to take the moments about B. I decided to take the moments about A. So I'm going to get the position vector of D with respect to A from observation. It's just coming positive, away from here, 480, and you have to go in the negative Z direction by 240. Also take a look at the position vector of the reaction B, and we can define those two reactions by the generics, and we also we were told that it has nothing in the Z direction, right, axially, right? So that's this direction right here. So there's nothing that's going by here. Here's the position vector that's also taking place to the center of the thing, and it's just 240 and 240 over. So the sum of the forces, I didn't write this out right here, but probably should have written out that we just added up CD plus RA plus RB plus the weight, right? So that was that right there is what's being expressed in here, but here's in the I and the J and the K, and so these are all equations right here that we'll be using after we get done establishing. So we take the sum of the moments about A, so R cross F, and I might have actually even squeezed in here the MI type of thing, just to remember that if any of these had supported a moment, there'd be a moment reaction, and it would appear inside here as just a straight number. It could be mx, my, mz. This is a straight variable, I should say. or if there's like an external moment being placed on there. If somehow somebody was sticking in some telescopic wrench thing that didn't put any forces into the thing, it just injects an exterior moment onto the thing. So if you had like I don't know if you ever seen they could have it's like a little twisty cable inside another cable, and then maybe you put a socket onto the thing, right? And so you're spinning something like a handle over here, like a rotor kind of dealy, and it's putting a moment onto there. That would just be an external moment that was being put into whatever the thing was. I mean, it could be like attached right here, and it could be turning the axis along the z-axis right here. That could be an external moment that was being applied to the thing. Just recognize you need some a method of putting that moment inside there, and that is not an R across F. That's some external moment. So it could be a reaction, it could be an external moment, but you need to account for the ability to put that in there. So we don't need to see that. So here's the representative of, with respect to A, of the different things, that force at right here, the tension and the position vector, and the weight in its position vector, and then lastly the reaction in its position vector. And so writing those out, we have the position vector and the force as we define them for each of these, and writing it out longhand. Continuing on right here, sample problem 4.9 continued. Let's see. So I have left off a lot of the zeros in here. So I went I, and I take a look, and that's going to be 0, but this is not going to be 0. So this is going to, but it's going to be subtracted. So it's negative this, which is negative times that, times I, right? So negative FCD right here. And then we take the J's, and we see, we have this cross and we have that cross, right? So we do have terms, but remember that the J is always the negative one. So we have a negative of that crossed with that, right, times J. And then we also have a negative, and then we have a negative, but it's subtracting, so then it makes it a positive. And so we have that one times that one, or that one times that one, FCD, that's J, right? And then coming down to the K, we have this one times this one, right? That one times that one, times K, and fortunately that one's 0. Yeah, okay. So, and now we want to move on to Da, U of H book, so that's great, thank you. In the I, this times this, that's nice, but now we have that one time minus this one times this one, so I have to go minus right there, that one times that one times that one, times I, boom. And then take the J, that times this, and that times this. Ooh, no J's, yay for that. Now we have K, we'll have this times that times K minus, those are nice. So right here, this is the 240 times this, 240 times that, and got a K. Moving on to the next one, I, boom, boom, we're good. Oh, but this one, yeah, that one comes into place, but we're subtracting it out, right? So that's that times that I, and then going the J over here, this times this, minus this times this, but it's, remember J's minus, so we're minus, okay, so we add that in there. And then K, 0 times this, and 0 times this. So this right here is the full expression of everything inside here. And what we do is we collect the I's. And you notice, okay, we have an equation there. All right, well, we have two unknowns. Okay, so we move down to the J, onto the thing, collecting the J's together. We have, where did the J's go? There is a J in here. I'm missing a J. Oh no, it's up here. Okay. We have J's. J, J, and J. Right. So J, J, and J. All right. So okay, we have 3 unknowns right in here. No, we actually have 2 equations, 2 unknowns. We could have solved that, But is that true? No, okay, these aren't the same. Yeah, no, couldn't do it. But we do have this one in the K. We only have two members of the K, here and here, so we're able to solve for FCD. Yay! And we're able to get that, and then we're able just to plug that back into here and get what the reactions at B are going to be. And then we're able to go all the way back to these equations up here, plugging in the now known tension and reactions at B, and get the reactions at A and the X, Y, and Z. And so now we're able to find all the things we wanted to know. Tension in the cable, reactions at A and B. That's a lot of work, man. But it's a puzzle. Figure the puzzle out. Work through the puzzle all the way through. And let's take a look and see what the ye olde bookie had to say about the thing. And so there's the problem. And here is them working through the thing. Here's their free body diagram onto the thing. I don't like putting that cable in there. It looks like it's still connected. It's not. It's not part of the free body diagram. They define the weight. They get the tension. Once again, I don't like capital T. They get the forces right here, right? So there's all the forces, and they write out them as unknowns. Here is the moments equation, and they're just plugging them in and working through them without like really showing you how the process. I like to keep showing you the process because some of you aren't getting it right. And then you can get what the reactions at A are going to be, and then get a Z and B, and you're getting the same values. And they tell you that they want you to reflect and think about it. But yeah, we are golden, right? So it was an abbreviated one, but it was just to try to make sure that you digest it. And I didn't like this problem at all because it's like kind of they're turning the thing on its ear, trying to be kind of cutesy and trying to figure out what position something needs to be in order to make something. It's long and involved. I don't know. The problems are tough enough without trying to play little games and figure out what the position of the thing needs to be. But here we go. There's another problem, at least described, even if it's not worked out all the way.